All right, everybody, let's get started. Good afternoon. My name is Neil DeMazier. I'm the Vice President of Sales and Marketing here at Imagine. And this is Imagine Academy Quarantine Sessions number 10. This is all about the Roland DWX-52D. It's also applicable to the 52 DCI. And it's kind of a back to basics type of session where we talk about how to set up the machine, how to get the most out of it, how to keep it calibrated in good working order, things of that nature. So we're going to be getting started in just a few moments here, but in the meantime, a few ground rules for you. If you could, please keep your microphones and your video off throughout the course of the presentation today. That'll allow us to focus on the presenter. And of course, as always, if you have any questions throughout the course of the webinar today, we encourage you to ask those whenever they occur to you. You can use the chat function down towards the bottom of your screen there to send those messages on through, and I'll be keeping an eye on that throughout the course of the webinar, and I can relay any questions to the presenter when we have a moment to get to them. We'll also reserve some time at the end of the presentation today for just a general Q&A about the Roland 52D or DCI dental mill. So aside from that, if you like what you saw here today and you want to see it again, or you want to catch up on some of the previous Imagine Academy quarantine sessions, which we've been doing these, gosh, for about the past month or so, one or two a week. We're posting all of them to our YouTube channel, which you can find us on YouTube just by searching for Imagine USA. You'll come across, several quarantine sessions on a variety of topics, so I encourage you to go check those out. And then, of course, if you like what you see here about the Roland 52D and you want to talk to us more about bringing one of these into your lab or into your clinic, you can certainly find us online at imagineusa.com and talk to some of our CAD/CAM experts, including the person who's going to be presenting here today. And that brings me to our presenter. So joining me today is a gentleman by the name of Foo Dinh. He's one of our technical support staff. He also handles installations and trainings for us, and he's kind of our resident expert about the Roland 5-axis mills. He's worked for them with them for quite some time. Used to work over at CAP a little while ago, and has recently joined the team. So without any further ado, Foo, if you could go ahead and turn on your audio and your video, we can get going here on the Roland 52. There he is. Hey, Foo.
Hello. How is everybody doing today? 1 second here.
All right.
You see the
Yep, I can see you
right?
just fine. Yep, you're looking good.
Good afternoon, everybody. My name is Foo. I work with Imagine. I am part of the support staff as well as the resident Roland expert. I've worked with these mills for a number of years now. We're just going to go through just the basics, really, from unboxing to installing tools, how to install the workpiece, and some general maintenance and general troubleshooting for the mill. Move this over here. Okay, so contents, like I just explained: unboxing, setup, installation, software. Couple things you need to do before to actually use the mill: tool installation, workpiece installation, maintenance, and some troubleshooting. Okay, now when unboxing the mill, a lot of customers tend to throw away the boxes that sit right on top of the mill. We try to tell customers to read the packaging before doing so, because they do label on the box to not throw these specific boxes away because they contain all the necessary accessories that is going to help you set the mill up to be able to use the mill.
You know what, I think that's something that a lot of people aren't expecting when they get a Roland 52D is like, Roland really went above and beyond in making sure to include everything that you're really going to need with the mill. But aside from including everything, they did a really creative job of kind of merging the packaging together with the holding for the accessories. So it's easy to miss them. So yeah, that's great advice. Just kind of double check everything. Don't assume that anything is just a packaging you know, or protection carton. Look inside everything and make sure you've got everything that they sent you.
Yes, open every box that you see. Worst case, nothing's in there. Best case, you know, you have all these accessories that you will need down the line. Okay, here's another photo of the accessories that come in every box, from the power cord, USB cables, to the adapters, the tool holders, the brushes, screws, and the vacuum hoses for your vacuum. When unboxing the mill and the mill is set up on the table, they put foam pieces inside the mill to keep the axes from moving. It's very, very important to remove all three of these foam pieces. Okay, if you do not remove them, the mill is going to crash and we're going to run into a bunch of errors that we don't need. So there's one where the tool changer is that keeps the holder from rotating. And there's two pieces that are behind a maintenance door above the tool holders. Okay, a lot of people don't know that that door's there, which is why they never remove the foam pieces and we run into troubles. But that is a maintenance door that you are able to open down to, you know, lube the rails if need be, and to especially to remove these foam pieces. So the spindle can move from left to right.
And actually, I think that's also the same door you use if you want to replace the spindle eventually, right?
That is correct.
Yeah, which is also another really cool feature about the 52D and DCI is that it is a user replaceable spindle. And I know a lot of people say, yeah, you know, user replaceable. I'm sure it's quote unquote super easy. But I can tell you, having done it myself, and I'm not a member of our technical staff. You know, it's really something that somebody with basic tools, basic skills can do, which I think is a huge advantage of this mill.
Yep. It's really, really easy. And believe it or not, the torque wrench that comes with this mill, you should be able to use to actually remove the spindle.
Nice.
So setting up the dust collector, the vacuum for the mill, there's two ways of doing it. They include two hoses for you, one short and one long. Now you can do direct with the short hose depending on where you have the dust collector, and skip the adapter that goes on the side of the mill. Now, if the dust collector is relatively far away, then you can use both hoses as well as the adapter to, you know, run it to whether the dust collector is in the next room or below or above. They really tailor, give you enough hoses to tailor how you want to set your lab up. Now, if the dust collector is far away from the mill, then you just want to make sure you have a really powerful collector to provide enough suction to get the zirconia dust out. Now, what comes with the bill for the link cable to let the dust collector know when to turn on and turn off is a ferrite cord. Now, this provides protection, keeps away the static interference from, you know, other mills, computers, cell phones, and stuff like that. So the dust collector doesn't turn on automatically or turn off while you're milling.
Which it's one of those little parts that I'm
Yep.
sure people have just tossed and thought, how much of an impact can that have? But you're totally right. You know, static, you know, EMF interference can, like you said, cause the vacuum to turn off when it should be on, or on when it should be off. And, you know, turning on when it should be off is an annoyance, but it's not a big deal. But turning off when it should be on, when the mill is milling zirconia and you need that zirconia dust to be removed, that can be a real problem, you know, because zirconia dust is highly abrasive. And if you just leave it to roam free within the milling machine, and that happens in an extended period of time, you could have mechanical problems. So it's a little thing that can make a big difference, right?
Definitely, for sure. And I've visited labs where I don't even see the ferrite cord at all. Right. And when I asked them, it's like, oh, we didn't even know. And more than likely, it's been thrown away.
Yeah.
Setting up the regulator, real easy. 2 screws right onto the back of the mill. And on the regulator itself, it should show you the direction where the air is going. Okay, so you always want to get that right. If we do it the opposite way, we're never going to get air into the mill while it's milling to blow off excess zirconia dust. Okay, now if you do put the hoses in the wrong way. It's a press fitting. It's real easy. You just push the little tab there, and you should be able to pull the hose out and change it up. Okay, setting the air pressure for the regulator is very, very important. If we put too much, it will cause issues. If we put too little, we're not going to get enough air pressure to blow away the zirconia dust as it's milling. Okay, the pressure we need to set it at is 0.2 MPAs. Okay, on the regulator itself, there should be a green arrow that actually shows you where it should be, or the balance, or like the in-between, I want to say. Mm-hmm. Now, as the mill is being used, that arrow is gonna jump back and forth all the time as it's trying to take air in, and so on. Adjusting, it's easy. Pull the knob up, right to increase, left to decrease, left to decrease, right to increase.
There you go.
Yeah, threw me off a little bit there. But you do have to remember, once you made that adjustment, you have to close the knob, push it down. If you don't, then as the mill is milling and the mill vibrates, it's going to actually adjust the air pressure by itself, which is not good.
Right, because I believe, correct me if I'm wrong, Foo, but if the machine doesn't see a certain minimum air pressure, it just won't function. Is that right?
The mill will, it should function. It's not like the IMUSs where it will stop, because the IMUS needs the air pressure to change tools, open and close the collet and stuff like that. Where the Roland, opening and closing the collet is mechanical. Gotcha. The air pressure is solely to blow away the zirconia dust as it's milling, whether it be zirconia dust, wax residue, or PMMA residue, which is a big thing. Because the more dust that just sits in there, the more likely you're going to run into not good milling results.
Right. So this is kind of, just as much a protection on the machine as the vacuum is, right? Yes. A lot of people think that only the vacuum can protect the machine by sucking out the dust. And while, of course, that's true, it does. Pressurized air blown at the milling process kind of clears it away. And also, basically the two of them work together. You blow you blow air at the milling process to get the dust away from the milling process, and then you use vacuum to suck it out of the milling chamber.
Yeah, it essentially kind of gives it like a flow
right.
Throughout the mill. You get air blowing from the top of the mill down, and the vacuum's all the way on the bottom. So the dust is just going to settle out the bottom. As it's settling down, the vacuum's going to pull it right out.
Nice.
Okay. Now the firmware drivers in vPanel. If you don't have a CD drive, a DVD drive on your computer, you can download everything from their website, rolanddwa.com, under their support tab. If you do need the link to the website for any reason, just let us know. We will give them to you, so you can go right there. Installation of the software is very easy. Once you hit the install button, it's going to tell you which the following programs it will install. They have to be the driver, the vPanel, and manuals if need be. Now, all these slides, all these photos that we have in this presentation here is in the manual if you have it. If you don't have it, you can get a digital copy from Roland's website that we can give you links to as well. Mm-hmm. Okay. Now, the driver setup is very important because without the driver, the mill's not going to work. It won't connect to the PC. It's going to say unknown driver, and you can't really do a search to get these drivers, unfortunately. So we do need the drivers to be installed.
Right, which this is one of those mills that, there's kind of there's two types of mills out there, right? There's one that has an external computer controlling it, and then there's one that has the computer built in that controls it. And like you mentioned IMUS mills earlier, those I think pretty much exclusively now have computers built in to control them, whereas the Roland 52D, the DCI, the 42W, those all require an external PC to basically
control the mill,
right?
Yep, that's correct. Roland mills rely on a separate PC to control the mill, whereas the IMS, everything is somewhat built in one big package, right? Relatively more expensive, of course, but those are what make each mill so unique and different.
Right, different tools for different jobs, as I like to say.
Yep, definitely, for sure. Now, after the driver firmware and V panel is installed, before even using to mill the millet job, we need to do what's called a spindle run-in as well as a calibration, or as they call it, the automatic correction. Now, once the V panel is open, the mill's connected, and everything's good, you should see on the left on our slide here, it should say ready underneath the mill, the picture of the mill. And if it says ready, then we're good to go on and do a spindle run-in. We want to hit the little gear icon on the bottom of the screen there, then go right up to the maintenance tab. Now in the maintenance tab, there's a bunch of options here that we can choose. We'll kind of go through them as we go through the presentation. Okay, but the first thing we need to do is that spindle run-in. Now what the spindle run-in does is it's going to run the spindle, warm it up, as well as distribute the grease that's been sitting inside the spindle while it's being shipped, or sitting on the shelves for a period of time. Okay. Now, if you don't use the mill for about a week or so, you need to do the spindle run-in just to get everything kind of relubed in a sense and have it good to go. Yeah. Now, the spindle run-in usually takes about an hour. It's a little bit of a process, but it's a one button. You click it, and you can go, do something else if you have something else to do in the lab. Catch up on some cases, design some cases while this is going on.
I always like to say that spindle run-in is kind of like de-icing a plane. It's like it takes time, and nobody wants to do it, but it's a safety measure that you want to take, right? Because, like you said, these spindles are all packed with grease internally, and if it sits on a shelf or in transit, or even if you don't use it for a week or two, that grease all goes to the bottom of the spindle, and the area up towards the top is left without lubrication. And if you just go ahead and run it without doing the proper procedure to distribute that grease throughout the spindle, you could damage the spindle, and you'd have to replace it. So it's something that can be inconvenient sometimes, but it's far less inconvenient than having a damaged spindle,
Yep. And definitely, we don't want damaged spindles, and more than likely, you're not going to get good results milling either. Okay. Now, after the spindle run-in is the automatic correction, okay, which is the calibration. Now, I think I moved a couple slides around. I'm not sure. So the calibration requires the detection pin, which we have on the screen here. Now, the detection pin doesn't need to be adjusted or moved in any case. It just needs to go into the number 15 slot on the mill. Okay. Now, the tool changer itself is magnetized, as well as the collar that the detection pin has. Now, as you're putting the detection pin in, you should feel the magnet pulling the pin down, and it'll sit flush. Now, if it's not sitting flush like they have in the picture there, we need to fix it, because if we don't, we're going to get a crash, and a lot of bad things are going to happen. We're going to have a very bad day, because if we damage the collar, then we're pretty much down the creek, as they say, which is no good. All right. Now, the plate itself, it's pre-installed. We don't ever want to remove this calibration plate from the holder that it's in. We just want to leave it as it is. Okay. It slides into the mill fairly easy. If you feel any force, pull it back out, try to realign it, and slide it back in. It should go in with little to no force. Okay. Once it goes all the way in, there's two knobs that you're able to turn to lock the plate in place. Now, if you feel that the knobs are relatively harder to turn, I suggest taking it out, sliding it back in, just to be sure. Then if it's still hard, then you can use a little tool that they give you to kind of turn and lock everything in place as well. Okay, looks like a little guitar pick with prongs on the end of it. Okay, now once that is all in together, we go to the same menu within the V panel, to the gear icon, to the maintenance, and now we're going to hit automatic correction. Okay, now in automatic correction, there are some parts of the mill that need to be cleaned. Okay, especially where the puck sits into the holder inside the mill, as well as the calibration plate itself and the pin. Okay, now since these are, I'm assuming this is brand new, of course, You shouldn't need to clean it much, but it doesn't hurt to take a dry rag, microfiber cloth or anything, and run through it again. Okay, but if you're milling and you want to calibrate for whatever reason, whether you see an inconsistent results or you're doing call out maintenance and you need to calibrate, then we want to clean it with isopropyl alcohol and make sure there's no zirconia dust. Any bit of zirconia dust will cause continuity issues that will keep the mill from making an electrical connection to calibrate the mill. Okay, so
That's
when doing
about this process to me is that you're using that calibration tool that you put in slot number 15, like you said, to make an electrical connection between that and this calibration disc here, and essentially that's what tells the mill exactly where sort of the moving parts of itself are. So it's a really, really important step. And like you said earlier, it's something that, yeah, of course you have to do it initially when you first kind of fire up the mill and get it going. But, the smart users of this mill, build it into their regular maintenance and do it, in your experience, Foo, what's the best kind of maintenance automatic correction interval? Is it once a month? Is it once a quarter? Is it once a week?
It'd be once a month or relatively every 200 hours that the mill is being used. Yeah. Because along with the calibration is the call-it maintenance that we're going to get to towards the later on in the slides.
Cool.
Okay, which is the maintenance part of it. Okay, which is very important that you will need to do. If you don't, then the call-it essentially is going to go bad and you're going to have to replace it. Okay. This detection pin, these are blown up photos, so you know what they kind of look like. Okay, and these are the certain areas that need to be cleaned when you're doing the calibration, after you use the mill, if there's like zirconia dust or anything like that. Okay, 2 parts on generally the entire detection pin itself, okay, and the correction jig or the calibration pocket, as they say. All right, now you can clean it with the cloth that they give you, or you can clean it with a microfiber cloth. Either or, it's not going to hurt it. Okay, I would try to refrain from using water, even though it's stainless and it's chrome and all this fun stuff. We want to keep this stuff from rusting at all. So if you do clean it with any liquids, isopropyl alcohol works the best from what I've seen. Sometimes Windex may help as well if we're really having issues, but very seldom you'd have to use that. We want to make sure it's really dry. And then we can go ahead and do the calibration. Next here is the tool installation. Now, the mill, I don't think it comes with a set of tools, but if you do buy it from us, we do provide a set of tools. Is that correct, Neil? Like a starter kit, something like that?
Yeah, most customers that order the 52D from Imagine, get a starter kit with it. I think it does come with some basic tools.
I think a few carbides or something like that.
Yeah, but depending on your application, our CAD CAM guys will make sure that any new users get the right set of tools to get going with.
Yep. All right. So a few things here. Milling burr, of course, are the actual tools itself. These tools will need to be installed by you guys. Relatively easy. If you follow these, simple steps here, anybody can do it. Okay.
This is basically a process that you do anytime you load a new tool into the mill. So you get a fresh, brand new tool. It doesn't have that little ring on it, and you use this sort of the mill burr positioner that they have here to basically install that ring on the shaft of the tool.
Correct. And now we got to be careful here when doing this as well, because I have seen customers where they install the milling burr holder, the little round collar, upside down. And what happens at that point is, because one part of that collar is magnetized, right? So when it's installed upside down, the tool changer, it won't pull the tool to sit flat. Okay, it'll essentially just drop in there. Some customers may not notice it, which is which is okay that they don't notice it. It's fine. But what happens is when the tool gets picked up and being used, and it does the measurements, it mills the job, and now it's done with that tool, and it goes to switch to another tool. Now the magnet on the collar itself is magnetized to the collet, to the spindle.
Right.
So it's never going to release the tool, no matter how open that collet is, right? And then that, boom, we don't get any crashes. We just get a tool error.
Right.
Okay, saying, tool too long, tool broken. We'll get an error, and the entire job's going to stop. Okay, I've seen that happen numerous times.
Yep.
New users especially, that they hire new people and they don't walk them through it as much, or the people don't pay attention as much, and it happens.
It's a small thing that can make a big difference, right? But it seems like on the milling burr holder, they make it pretty clear which side is the right side to be facing the cutting end of the tool, right?
Definitely does. The problem that I've seen is they don't use the milling burr positioner. The holder.
There we go. Use the tools that are included. That's the moral of that story.
Yeah, they try to eyeball it, which causes problems like that, as well as other issues that you run into when it's measuring the tool. Okay, now with the holder, fairly simple. Once the collar is in the proper way, where you can actually see the screw, you loosen the screw, you slide the burr in. Okay, now you want to make sure that it's aligned within the little gaps that are on the burr positioner. Okay, that's Roland's, I want to say, midline, recommended positions. Now, if it's a little bit too long, then the collet itself is not going to have enough tool to grasp and make a strong, a tight hold on the tool. If it's too long, we're going to get errors where the mill is going to say the tool is too short. Okay, so it's very important to make sure it's lined up in them as middle as possible within those little gaps that's on the milling burr positioner. Okay. Now, once the tool is done and you install it onto the collar, you put it into the mill, you need to remember where you put these tools. What I would suggest, instead of putting all the tools in at once, one at a time, make your adjustments within the V panel so you know what tool is where. Okay. Now, to make set adjustments to let the mill know what tool is in which position, we go into the V panel again, but instead of using the little gear icon, we're going to use, it looks like a drill icon with the little clock next to it. Okay. Once we click that, we get what's called the milling burr management. Now, with the 52D, you get 15 sets of tools, or 15 tools that you're able to use. Okay. On the right side, where we see zirconia R1, 3, R1, 2, R1, 1, is where the tools are actually named, the description of the tools. Okay, those are just defaults. All that can be changed within the milling burr registration. Okay, now in the milling burr registration here, we're able to add milling burrs if we want to, remove milling burrs if we want to, adjust the work times on it. If you have like an old tool you use for maybe 5 hours or so, but you decide to use another tool, you can say, you can write that time down on a notebook or something. And when you go back in and this tool has 5 hours on it, you can add that 5 hours worth of work time on there. Okay. As well as, changing the replacement times. Right. Now the replacement times lets the mill know how to adjust their graphs as far as tool usage here. Now on the right, as you can see a few examples, usage less than 75%. It should be a blue graph, not green. Little typo that Roland has yet to fix in their manuals. Hopefully they'll get on that as soon as possible. Yeah. But it's supposed to be a blue graph. Now, if it's in the blue, you have the usage is less than 75%, right? Now, if we get in a yellow graph here, it's more than 75%. Which is, it's almost time to replace. Typically, once I see yellow, I'd like customers to know, replace it. Don't throw the tool away, of course. You can save the tool just in case you're milling a job where it actually uses 100% of the tool and it stops, right? You can just throw that in for a quick finish.
Yeah, just a backup.
Now, yep, nice little backup for whatever reason. Okay, now when it's at 100%, it's going to be all red. It's kind of like a clock, essentially. Okay. Once it's red, it will not pick up the tool. It will pick up the tool, but it will prompt a message for you that'll let you know the tool life is done. Right. Are you sure you want to continue? It's not going to stop you from doing it, but it's going to let you know that, hey, this tool's done. The replacement time is we hit it, it's there. You got to change out the tool. Okay.
Yeah, this is an important, thing, because a lot of people, we talk to a lot of labs and clinics that are thinking of, bringing their first mill into their business. And one of the questions they always ask is like, well, how do I make sure the tool's not going to break? Like what happens if the tool breaks? And the best way to avoid that, well, I mean, the best way to deal with that problem is to avoid it completely. And the way to avoid it completely is by this information right here, basically letting the machine know how long any given tool can go before it's expired, right? And
Yes.
in that way, because there's only two things that are going to cause a tool to break, right? Either you're cutting with it past the point that it's sharp anymore, right? And then your cutting forces are so high that it'll break the tool because the thing is so dull, or the tool is nice and sharp, but your cam or your milling strategies are wrong, right? Now with a machine like the Roland 52 or D or DCI, these are already highly refined milling strategies that aren't going to break the tools, right? So it's really the only thing you have to worry about is running it too long past the point that it's sharp enough to do an adequate job cutting, and then it'll break. But that's where this little graph that you have here comes, saves the day.
Yeah, definitely, for sure. And when the milling burr is dull, not only will the tool break, now we're just wasting zirconia.
Right.
As the result.
Yeah.
It becomes a domino effect, basically, and we're just kind of throwing money away. We don't want you guys to do that. We don't want to do that. Definitely. So try to stay on top of these replacement times. That's why I say when you see 75%, you see yellow, I just replace it.
Yeah.
All right. It's better than going a little bit more than you run into an issue on like an all-on-4 job, a bridge or something like that, and now the bridge looks like crap, or the tool broke and now it's embedded into the bridge. It's a
whole case. You got to start over again.
Yeah, it's a huge mess.
Yep. Now, one thing that I've seen a lot of labs do, Foo, if you could go back one slide to the, there we go. These different slots, 1, 6, 11, 7, 12. In your experience, do most labs kind of have a very consistent, hey, this zirconia, our 2 millimeter zirconia burr always goes in slot 1. The 0.3 always goes in slot 11. And it's that sort of consistency that allows them to avoid errors. Is that your experience?
Yes. So the way the tool listing needs to be is how the CAM software is set. So if the CAM software that you're using uses tool number 1, number 2, and number 3, you need to make sure those corresponding tools are in the mill as it is. So for example, what we use in the 1 slot is the 2 millimeter burr. Number 2 slot is the 1 millimeter burr. Number 3 slot is the 0.6 millimeter burr. Okay. Now I've seen it where labs don't really pay attention to that much, and they kind of switch everything around a little bit, right? Where slot 1 has the 1 millimeter, because that sounds like it makes sense.
Right.
Number 2 has a 2 millimeter, which makes sense. Number 3 will still have the 0.6 because you don't really put it in the slot number 6 like that.
Right.
We always want to try to keep it in a row. And what happens is the mill is not going to say, oh, yeah, 1 has it's the wrong tool. We can't use that tool. It's still going to go pick up that tool, all right, and do all its roughing with that 1 millimeter tool.
Right.
Yeah. More than likely, the tool's either going to break, or you're going to get really bad results, as the cutting lines are going to be very small, and it's not going to be fun.
Yeah. Yeah.
Okay,
At the end of the day, the mill just does what it's told, right? It's
definitely.
As I like to say, mills are dumb. They just do what they're told, right? They don't have any brains. They're all muscle. And it's the CAM software that's all the brains of the operation. So a lot of times, especially if you're a new mill user, one of the best kind of skills you can learn is to try to understand when you see a problem, is it actually a mill problem, or is it a CAM problem, or is it user error? So in this case, it would be easy where, the user put the wrong tool in the wrong slot, and the mill did the wrong thing. It would be easy to point to the mill and be like, the mill's bad. What the heck? But but it's, you know, it didn't decide in and of itself to mill the part wrong, you know. It's just,
Yeah.
it's just doing what it's told, you know.
Yep, definitely. When doing the tools, just double check and make sure. That's why I like to tell customers to do one tool at a time. Okay, so that way you know that's the tool you're putting in there. Whereas if you just throw all the tools in at once, and now you're going into the the burn management and kind of setting things, right? You're gonna kind of, oh shoot, which I forgot what tool's there, and now we're just wasting time pulling tools out and seeing which one is where. Okay, double check takes a little bit of time. And you're going to be fine. Okay. Now, when installing the new tools, okay, what we need to do is called a milling burr change test. I'm going to go back a couple of slides here, right here. Now, the milling burr change test, sorry, one right there. It's under the ATC in the maintenance tab of the settings. Okay. When we click that window, it's going to open up another window to say which tools you want to test. Tools as in which slots do you want to test. Typically it's 1, 2, 3. Okay, now what that does is it picks up the tool and it's going to go and test the length of the tool against the sensor that the mill has to make sure that it's within spec of what Roland uses themselves. Okay, now what that does is if you're using, let's say, an aftermarket tool, not ones that's not from us or from Roland directly. Let's say one from China or something like that.
ABC.
Yeah, ABC tools, right? If the length, even though you have it in the box, in the burr positioner as centered as possible, if the length deviates from what Roland typically uses, you're gonna get an error, right? And that tool's not gonna work. Okay, even if you change the geometries in the cam side of the software to match it up, if it doesn't fall within Roland spec, then it's not going to work. Okay, you're going to run into issues 100% of the time.
And that's probably, those specs are probably written to avoid collisions with the moving parts of the machine, because if a tool is too long, there comes a point where you can't rotate the A or B axes without impacting the tool if the tool is too long. So
without crashing.
They didn't just make those settings to try to force you to use their tools or something. You know what I mean? It's to prevent real problems.
Yep, you could definitely go and get tools as long as they're within Roland spec. You're good. You just got to make sure the cam side of the software has your tool geometries and all that fun stuff. Make sure strategies work for it as well. Okay. Now, every tool change, with the first time you change in tools, second, third, fourth time, always do the milling burr change test. Okay, so it registers that stuff. Now onto the workpiece. Now when you purchase the mill, it comes with a set of workpieces here, holders, puck holders, I want to call them. Keep it simple, and they are all the same. Essentially, the workpiece that the calibration plate comes in a puck holder like this, but we don't want to remove the calibration plate and put a zirconia puck in and decide to use that to mill. Okay, they gave you plenty to not use the one that the calibration plate came in. All right, so just put that away, put that aside. Don't even touch it unless you're calibrating.
Off limits.
Yes, 100% off limits. Don't touch it. All right. Now, 4 screws hold the puck on. Okay. It comes with a torque wrench that you will use to remove and tighten down these screws. Okay. Take 4 bolts out. The adapter cap, it slides clockwise, then it pops up. Go ahead, put the workpiece in, put the adapter back on, slide it counterclockwise, then you tighten everything down. Now, you always want to tighten everything down in star padding. In this case, a crisscross padding. One side, then you go to the other side. Then you can go whether it be down or left, however you want to do it. But you always want to do it across from each other, never in a circle. If we do it in a circle, it's going to give us uneven clamping pressure on the zirconia puck, and that will cause us issues. Okay. Yep. All right. Now to maintenance. This is just simple maintenance. All the maintenance that you're going to do on the mill, it's easy. Nothing's difficult. You never have to call us to send somebody on site to do anything. It's all you can do in-house, and Roland provides everything that you need to do it. Okay, like we said earlier, when moving the mill or not using the mill for a period of time, we want to do that spindle running. Okay, so it warms up the spindle, distributes the grease evenly. Okay, now if you're moving it, do the spindle running as well as the calibration, the automatic correction. Okay, if you ever need to replace the spindle unit down the line, of course you need to do the spindle running as well as an automatic correction. Okay, because now instead of it being inside the mill, it's just in a little box that's been sitting, you know, on the shelves just with the grease settling to one part of the spindle. Okay, all right. Calibrating the mill, like I said, same thing. If it's being moved, you're doing the spindle run-in, you're calibrating. Okay, if you're getting issues where the milling position's not aligned, where, you know, if you set a unit in the middle of the puck, but it's milling a little bit, you know, more to the right or more to the left, then we want to do a calibration to get everything recentered. Okay, I've seen that happen once or twice. It's not really a big deal because you can make some adjustments in the cam side to reflect where it milled, so you don't really lose the puck. But if you were to, you know, let's say you filled out the entire puck, right, and for some reason it shifted, right, you're going to be milling into the puck holder,
Right.
Okay, and breaking tools, and that's a no-no.
Yeah, that's that kind of thing. It's I know it can be when you see that sort of thing in a lab and, you know, there's a lot of work to do, it can be easy to just say, you know, it's shifted a little bit to one side, but what's the big deal? Let's just run it. You got to pay attention to those type of things, you know, from any milling machine.
Yes.
Because if you ignore them or just try to brush them under the rug or forget about them and hope that it goes away, it's probably not going to go away. And it'll probably just make the problem worse. Like you said, Foo, down the road when, you know, the next puck you put in, instead of milling one unit out of the center, you've nested the whole thing. And as it gets to the perimeter, since it's shifted to one side or the other, you're milling into the puck holder, damaging it, breaking tools, having a bad day.
Yeah, it's one of those things that it may be okay for this one run, but it's going to come back to haunt you if you don't, you know, get it squared away now. Calibration takes maybe 5-10 minutes. It's not going to hurt, you know, while you're designing or, you know, prepping that restoration or whatever the case may be. Just let it do the calibration, and you're good to go. Okay. Holes in the Z direction of the milling, if it's milling too deep in the unit and you start to see holes coming out the side of the coming out the bottom or the top of the crowns, do calibration. Okay, just like it's being off-centered from side to side, now the up and down is off-centered.
Right.
Okay. Tightening the collet, like we mentioned earlier, once a month or every 200 hours of mill use. Okay, actual milling time. Okay, now within the V panel, it tells you right here, the spindle time, work time in the middle of the screen. Right now it says 7 hours, 8 minutes. When you see that hit around 200 hours, we want to do, excuse me, collet maintenance. Okay, after the collet maintenance, do a calibration. Okay.
And collet maintenance is a pretty simple procedure. You're just double checking to make sure that the collet is tight in the spindle, because the collet is the thing that, you know, comes down and clamps and actually grabs the cutting tool. So you want to make sure that that thing is nice and tight, right?
That is correct. Relatively easy to do. Roland has videos on the collet maintenance. If you do need a link to that, just let us know. We'll give it to you. But you can just YouTube it, you know, Roland 52D collet maintenance, and it'll pop right up. Goes with you step by step, even through the V panel, on how to do it. Okay. The one thing it doesn't show you is, I believe, the automatic correction at the end. We always want to do that anytime we do anything with a collet. Okay. Any little shift or adjustment that may or may not occur while doing the collet maintenance will affect the calibration of the mill. Okay. So the collet maintenance in turn runs with the calibration once a month or every 200 hours, whichever comes first. All right. If you sorry?
Doing that sort of thing, it's you know, I always like to say, you know, a mill is like a car. You know, it's just a machine, and if you take care of it, it will take care of you. You know,
Yep.
But nobody expects their car, or I think very few people expect their car to just keep going and going and going forever without maintenance. Well, we can't expect the same of a mill either. And getting into the habit of, like you said, Foo, doing this sort of once a month, or every 200 hours. Just do it. First Monday of the month, just do the machine calibration. You get into that habit, and your machine will be happier for it. It'll be more reliable. It'll have better longevity. You'll get more consistent milling results. It's all pros, and hard. There's really no cons to it. So it's time well spent.
Yes, definitely. And it's not a ton of time either.
Yeah.
It's not going to take you an hour to do all this. It's going to take you 5-10 minutes tops.
Yeah.
Okay. And that goes a long way, a very, very long way,
yeah.
As far as, keeping costs for the mill down. Right.
And I would say even if you're not at 200 hours, just do it once a month. Because 200 hours a month is what? It's about 45, 46 hours a week. Your mill might not run 46 hours a week, but still just the same. I would say it's better to err on the side of safety and just do it at the beginning of every month.
Yeah, definitely, for sure. Now, we don't want to do, I'll call it maintenance every day. That will be a problem. Okay. It does put stress on the call it if we do it consistently every single day. Don't do that. Okay. Yeah. So we want to refrain from that. Once a month, every 200 hours, the least. Okay. All right. Now, water and dust accumulation. So where that comes from is really the air regulator that's on the back of the mill. Okay. I want to say at least once a month while you're doing the calibration and the collet tightening, you just want to crack. There's a small screw on the bottom of the regulator. Right here on the bottom of the regulator. You just want to crack it open to let any excess moisture or dust that gets built up within your compressor out. Okay, because if we let that dust or that water pile up, the higher it gets, the closer it gets to shooting water inside the mill.
Right.
And we do not want that. We want zero moisture in the mill.
Yeah.
Okay, that becomes a bigger problem than it needs to be. Okay. Simple stuff. You can do that along with the collet maintenance once a month. Okay. If you have a really bad compressor that accumulates a lot of moisture, then I would say definitely once a week.
Right. And that's something that's easy enough. It's a transparent bottom, right? So you can visually check it, right?
Yep. You can see through it. It's not all black and hidden or anything like that. You can see right through it. You can see the accumulation.
Yeah. Great.
Okay. Yeah. Now, last but not least for the maintenance, vacuuming out the mill. Depending on how much you mill, if you mill a lot, once a day, right? If you're not milling as much, every other day or once a week. But we definitely want to keep the inside of the mill as clean as possible. Okay. We don't want to drive around in our cars, with junk all over the place. At least I hope. We want it relatively clean. Okay. So the cleaner the mill, the better it's going to run, the less issues you're going to run into, the less zirconia build up in certain areas that will cause, issues and stuff like that. Always keep it clean and you're good to go.
Yep.
All right. Now we're going to go through a few troubleshooting steps, fairly simple stuff that you might run into as you're using the mill for the first few times. Okay. No data being outputted to the machine, or the machine's not even doing anything even when you send a job to the mill. All right. Easy things to look for. Make sure the door is open. Make sure the mill is not paused. On the mill itself, where the blue light is in the middle, it looks like a button. If you happen to press that without even knowing it, it's not a click button or anything like that. It's a touch button, touch sensitive. If you touch it, the mill's going to pause. Okay. And you're going to look at it, after 5 or 10 minutes, say, well, the mill hasn't moved for a while now. What's going on? Right. Could be because it paused. Okay. And you just hit it and you're good to go. Could be connection issues with the USB cable. Now, Roland provides their own USB cable that you really, really, really need to use. I can't stress that enough. You have to use this specific cable.
It's one of the funny things. Like, I don't know what it is about that cable. It's like some sort of super duper cable, but I remember, being at Roland and then them telling us, be like, hey, just, trust us, use the cable that comes with the machine. It's another one of those where it's a little thing, but you know, if you swap out the cable just because, you know, I don't know, you want one that, you know, looks snazzy or whatever, you could very well introduce a whole slew of problems that'll seem really enigmatic, and you're like, what is going on here? And at the end of the day, it could just be the darn cable.
Yeah. You can buy the most expensive cable in the world. It can be made out of pure gold for all we know, right? But more than likely, you're gonna run into issues, and you're just gonna have to go back to using the cable that they gave you.
Yeah.
Okay. We're gonna make sure that the milling data, the CAM files that you're sending, is proper. If you're sending jobs that job files that the Roland doesn't use, it'll go through, but nothing's going to happen with the mill. The mill's not going to move because the mill's not recognizing certain steps that it's doing. All right. If you cancel the job on accident, right, but you still think it's sent through, because once you send a job and you minimize the V panel, that's really pretty much it. You know, you go about doing other things and the mill's not moving. Then when you go back and you look at the V panel, there's no job there. You know, little things, it happens. Happens to me sometimes as well. So it's not, nobody's perfect. Okay. So little things like that, it does happen, and it's a simple fix, right? Automatic correction failures. So calibration failures. Okay. The only times I've seen the calibration really fail is because the plate, the calibration plate itself is dirty, the detection pin is dirty, or the mill itself is dirty. Okay. By dirty, I mean full of zirconia dust. They don't clean it every day, or they don't clean it once a week, as much as they need to. Okay. And all that stuff gives problems because it doesn't let the mill have a connection with the calibration pin and the mill itself. Okay. It doesn't give us a good continuity to provide that little surge of power that they have to know where it is exactly positioned. Okay. Got to clean the mill. Make sure it's clean before calibration. It's a big must. And it's 90% of the time is why the calibration fails. The mill's just dirty. Okay. Even though you think it may look clean, right, after 1 or 2 jobs, clean it before you do calibration. Okay. That, believe it or not, that little bit of zirconia dust makes a big difference.
Yeah. Because I mean, all it takes is basically one particle of zirconia dust in the right spot to prevent that electrical connection that is, you know, required for the calibration.
Yeah, definitely, for sure. On the older roller mills, it was way worse.
Yeah.
You'd have to eat off the mill before it calibrates.
There you go.
All right. It had to be that clean. So it still needs to be that clean now. I'm not saying, you know, some zirconia dust where the vacuum is, that's not going to cause a big deal, right? But where the pin is making all these contacts, it has to be clean, 100%.
And it's probably, I would imagine that, you know, since the calibration pin and the calibration jig probably spend most of their lives in a drawer under the machine or next to the machine or whatever, they're probably not getting all that dirty, right? You still want to wipe them down with isopropyl, but they're probably not getting all that dirty. Probably where most of the problem happens is in the jig holding fixture, the puck holder within the mill itself, because that is in the mill all the time. There's zirconia dust accumulating, and if that doesn't have a good electrical, you know, connection to the calibration jig, you know, you could touch the calibration pin to the jig all you want, but we're not going to have that electrical continuity. So I would imagine, is that true in your experience, that it's usually that part of the mill where the puck holder gets loaded in that needs to be cleaned the best?
Yes, definitely, for sure. That, as well as the tool changer. Okay. Yep. You know, anywhere you can clean where these crucial parts are going, you got to clean them. Yep. Okay. Like I said, if you don't, then we're going to keep going through this over and over and over again until we ask you to send in some photos, and Jesus, you guys never cleaned the mill,
right?
You know, sure enough, you vacuumed it, a little bit of isopropyl here and there, problem's gone.
Everything works. Yeah, imagine that.
Right? Yeah. All right. Now, if we get chippings in the jobs, more than likely, the milling burr that you use is worn. All right. It's worn out, it's gone bad, and it doesn't mill it as cleanly as possible. And when the cutting tools are worn out and the edges aren't good anymore, instead of doing nice cuts, it's just going to start kind of chipping things away a little bit. All right.
Well, in that case, you'd want to go back to that tool life.
Tool life.
And just say, hey, all right, so I'm starting to see chipping here, and this tool has been used for 13 hours. Let's set that tool maximum life for this tool for whatever, 10 hours, 11 hours. And that should prevent that problem from happening again, right?
Definitely. And, depending on what tools you use, because obviously there's, non-coated diamond ones, there's diamond ones, there's a plethora of tools out there that you're able to use. So, milling times are going to change for all of them, working times, right? They're not all going to be the same. Some may be less than others. Some may be a lot more than others, all right? It's hard for us to put a solid number on anything because every tool is different. Everybody's use case is different. So we try to let customers know that, use a few set of these tools, 3 or 4 of them, right? Get your average in when you start to see chipping, record them, get your average out of that. If you're getting 13 hours out of each tool, that's consistent. That's great. Put it for 11 hours, right? Because, as soon as you hit 12, we're going to start to run into issues.
Yep.
Okay. Another thing is you want to make sure the mill is on a sturdy table. Okay. No vibrations or shaking or anything like that, because that will cause issues as well. As the mill's moving, the spindle's moving left and right. It does cause vibrations. Okay. And on a table that's not sturdy, you will see that the mill's going to start to go back and forth itself and shift and cause milling issues. Okay. We want to make sure the adapter is properly inside the mill. That means it's not loosey-goosey, right? Because sometimes if you put it in crooked, it's not going to lock in all the way, right? It's not going to lock in tight. And if you
the adapter, as in like the hardware that holds the puck into the mill,
the actual puck holder itself.
Yeah, gotcha.
Yeah, so that if you slide that in, it may go in and you're able to lock it in, right? But if you shake it and it's moving, we got to stop. Time out.
Yep.
We gotta look at what's going on here, okay? And that's when you try another holder. And if you're still getting the same issue, give us a call. We'll let you know what we need to look at and what we need to make sure is tight on the actual mill side itself, not the holder.
Right.
Okay. Now, if the mill side is tight and it's still loose, we got to make sure those screws that are holding the puck in place are tight and tight properly, in a star pattern. Okay. Crisscross, not from in a circle, because if you do it in a circle, that will cause it too, even though it's tightened down all the way. But once the mill starts putting that type of pressure on the puck itself and starts milling, right, it's slowly going to vibrate its way out. And
a lot of these things are, we talk about, chipping occurs, and I think a lot of people might associate chipping with margins, right? Chipped margins or
yes, more than likely 100%. Yeah.
And that's
which is margins.
A margin is probably the most fragile feature that any dental mill will be asked to produce. So it'll, you'll see the evidence of a worn out tool or some sort of other mechanical problem with the mill. You'll probably see it there first, but it's not like a chipped margin isn't the only place that you would see evidence of something mechanically being amiss with your mill, whether the tool is worn out and it's dull, or the puck adapter isn't, tightened down properly. You'd see, just variations in your milling result overall, right?
Yes. More, like I said, mostly margins, because it's very delicate there. But you'll start to see it at the connecting pins,
yep.
The support pins that hold it on. Because those are, even though it's not super detailed, it's relatively thin as well when it's trying to mill it. Okay, certain features, if you do with molars that have very defining anatomy, right, you might get a little bit of chipping on the occlusal side itself. It all accounts. You got to make sure tools are good, the mill's in a solid place. And just speaking of margins, if they're really, really thin, like paper thin, even with new tools,
Right.
you know, and this mill strapped in, you know, nailed to the floor.
Right.
It's hard to say that we're going to get consistent results with thin margins and not get any chipping margins.
Well, and I think that's what in this particular graphic where it says, are the milling conditions too strict? I think that's what they're getting at, right? Is hey, you know, you can have a perfectly set up and calibrated mill, a perfectly sharp tool, but if the brains of the operation, the cam, is telling the mill to do to manufacture something that cannot be manufactured, like a margin that is simply too thin, then it's just not going to work, period, right?
Yeah.
Yeah.
Definitely. Milling strategies play a big part in the mill as well. They need to both work in tandem. If they don't, one's gonna think it's doing the proper job, one's not.
Yep.
You know, they got to meet evenly here. You know, okay. After chipping, milling surface not attractive. Really goes into worn tools, making sure the workpiece is secured, the puck itself. You know, making sure the adapter's properly locked in place. You know, not wiggling, not moving. I know they put it separate here in the manual, but I'd like to think milling surface and chipping are one and the same as far as troubleshooting wise. We're looking at the same things here.
Yeah.
You know, bad tools, you're not going to get good results. You're going to get chipping. If the mill's not properly secured, you're going to get chipping, not good, not good results. Milling conditions are the same. You know, improper strategies affect the milling.
Yeah.
No matter how calibrated or, pristine the mill is.
It comes back to what we were talking about earlier of being able to, know the process between, cam, AKA nesting, and the mill, to be able to know when you see a problem, to be able to say, okay, what is the source of that problem? Because, most of the time when you set up a cam nesting software in a mill, and you get the cam strategies from a good reputable source like Imagine or somebody similar, you set it up. If you start getting deviations in the mill results, a lot of the times it will be a mechanical issue with the mill, because the cam isn't gonna, unless you go in there and change something, or unless you try to, design a margin that is ridiculously thin, the settings within the cam aren't really going to change, right? They're kind of dialed in and they're set, So if you see something go south on the milling result, if you understand that the strategies are set, and if I'm seeing a deviation and I haven't changed anything in the cam, then there must be something mechanically amiss with the mill, right? And then you kind of go through the usual suspects. Okay, is the tool dull or sharp? Is the adapter tight or loose? Is it dusty or is it not dusty?
Everything plays a part. They all need to work in tandem. Sometimes customers don't do collet maintenance on the mill. They don't tighten it every 200 hours or a month. Then start getting tool slips, start getting chipping even on new tools.
Right.
New tools, good calibration. Then say, well, when's the last time you did collet maintenance? Oh, what's that?
Right.
Well, let's start there.
It's what's going to save the day today. That's what.
Right, and more than likely it does. But oftentimes they let it go too far along,
right,
where the collet itself gets damaged, no matter how tight we try to make it. Then they have to buy a new collet. Right. Another thing is line level difference of the milling results. These, I don't see it as much, but more than likely it counts to tool slips. That goes back to collet maintenance. Okay. Also, oftentimes on the cam side, it skips the finishing step for some reason. That has happened to me, of course, where it just does the roughing and not the finishing on one side or the other, right? Also, if you swap tools, you're not putting the tools in the right slots, you're going to see these lines inside the your crowns and stuff like that. Then you're kind of wondering why, hey, it's not really moving a lot of material the first time, but you're like, oh, maybe that's just the way this one is,
right?
And you let it go through and it looks complete garbage.
Yeah.
Sorry, needless to say.
consistency, right? It comes down to consistency, right?
Yeah.
You know, if you want a consistent good output, you need consistent good inputs. And that means consistently putting the same tool in the same spot. It means consistently setting your margin thickness, you know, within a certain range and never going outside of it. Consistency is key with any manufacturing. And that's true for dental laboratory production. It's true for making cars or tables or whatever. You know, you want a consistent output, provide consistent input.
Definitely, for sure. Line shifts, you sometimes you will get where, um, good anatomy, great margin lines, but you'll see a shift in the crown, like a step essentially, where the bottom portion of the crown meets the top portion where the support pins are. If you run into issues like that, then we need to do a manual calibration. Okay, and that requires you guys giving us or your reseller a call, so we can send you proper tools and the equipment to mill out certain block, get certain measurements so we can enter it in and give it a go again. Okay, I've done that maybe twice my entire time working on rolling mills, so it's not something that comes up as often, but sometimes you will see it.
Sure.
Okay, and like when you do, give us a call, give your resellers a call, we'll help you out. Okay, easy one, spindle's not rotating. If the spindle's picking up the tool and you don't hear the whining noise that it usually makes, or if you do hear the whining noise that it usually makes, but the spindle itself isn't spinning, okay, we want to check to make sure the belt that's driving the spindle is still good, still there. And that's where we open up obviously we want to make sure the mill's off, not on. You turn the mill completely off, open the door, and we open the maintenance door. Okay, and we're looking inside. It's a black belt that connects to the spindle, real easy to see. If you do run into troubles, just give us a call, we'll help you out, not a big deal. If the belt's not there, then the spindle's never going to spin, no matter what we do, right? But if the belt's there and you try to spin the spindle with your hand and it's just locked, then you need a new spindle. Okay, that's when you call us, so your reseller, to get a new spindle. And if you need walkthroughs on how to replace it, we'll help you. It's not a problem. We'll walk through the videos with you. We'll stay on the phone with you, FaceTime, whatever you need to get you up and running as soon as possible. Okay, not that won't happen as often, but reasons why that would happen is you don't do spindle run-ins when it's been sitting for a period of time. Okay. Ionizer. Now, all these mills come with ionizers for PMMA, basically, because PMMA is very staticky. What the ionizer does is it pulls the static electricity from the milling chamber, so the PMMA bits actually just fall down instead of sticking to the windows, sticking to the workpiece, sticking to the side of the walls, and
sticking to everything. I like to call it the snow globe effect, because that's basically what it looks like.
It definitely looks like a big snow globe.
Yeah.
Now, if it's not working properly, we want to make sure it's cleaned. Okay, where the ionizer is. It's real easy to see. It has a small little blue light on it inside the mill. Want to make sure that area is clean. If it's not clean, we got to clean it up. Okay, we got to make sure the dust collector isn't clogged or anything like that. Okay, make sure it's clean, so you get the proper suction out of the dust collector. Okay, if all that stuff doesn't work and you're still getting these issues, we want to make sure the mill's grounded. Okay, now I haven't seen ionizers not function, so majority of the time we don't really ground the mill any more than it already is, through the wall, electricity in the mill itself. But if you do run into this issue, Roland should provide in the kit, it's a grounding plug. Okay, it's a mini extension with a ground wire that you can ground right into the building itself.
Right.
Okay, very, very, very seldom I've seen it used.
Yeah.
Okay, more like
you don't have a good ground connection within the electrical system of your building, which today's electrical standards, everybody has good grounding. So yeah,
yep.
It's few and far between, I'd imagine.
Yeah, it definitely is. So we don't really worry about the last part as much. And of course, if you don't see any lights where the ionizers as the mill is running, even for zirconia, right? If there's no light on and you decide to mill the PMMA job, we go through all this and it's not working, ionizer needs to be replaced. Okay, but like I said, very seldom I've seen any of that stuff happen. The ionizer is always working. It's not one of those mechanically moving parts that need to be maintained or anything like that. Okay, compressor. No air is coming out as you're milling, so you're not hearing a sound, and you're not seeing zirconia dust getting blown away from the milling area. Make sure the compressor's on. If it's on, make sure you're getting air pressure to the regulator. If you see the regulator and it's at where we set it, the 0.2 MPAs, then we want to make sure the line that goes inside is not cracked. Or if you hear a hissing inside the mill, it could be possible that the line ruptured for some reason. Not often, rarely, as a matter of fact. What I often see is when customers, the relief valve on the bottom of the regulator, they don't tighten it all the way.
Oh.
Right? And when you don't tighten all the way, all the air is just going to escape out no matter what you do.
Mm.
Okay? Or they have poor wall connections. So most of the time, labs have compressors in different rooms, and they're running copper tubing or wires, hoses throughout the office for these connections. If the air's leaking from that connection, we're never going to get consistent air pressure, right? So check for leaks. Make sure the knob on the regulator is closed, pop down after we're making that adjustment. Okay, if it's up, like I said, as it's milling, it's just going to slowly rotate and adjust the air pressure again. Okay, all right. That's pretty much it for the presentation. If you guys have any questions, feel free to ask or just send us an email or give us a call, and we'll be more than happy to help you guys out, answer questions as best as we can. My email is foo@imagineusa.com. Neil, I'll let you take over. The floor is yours.
Right on. Thanks, Foo. Great job, man.
Thank you.